Well done for making it through all of that legislation. In fact, we've only got one more piece of legislation that we are going to discuss in this course. So now we take a look at the practical application of what we have discussed, starting off with the safeguarding of machinery and equipment. Now, a machine guard is a barrier which suitably encloses the moving parts of a machine. It must prevent any part of the body from reaching under, over, around, or through the guard and entering the danger zone. It is necessary to safeguard machines because the injuries caused by machines could be severe, disabling, and permanent. Such injuries are generally preventable. Danger can often be reduced or removed by mechanical safeguards, and workers realize that unguarded machinery is dangerous. The employer should spend money on the safeguarding of machinery to show his sincerity in protecting the workers from injury. Let's now take a look at the different classes and types of machine guards. There are two classes of machine guards, namely transmission guards and point of operation guards. And there are three types of guards, namely fixed guards. These do not move with each operation. Interlocking guards. These guards prevent the control of the machine from being used until the guard is moved into place. And lastly, automatic guards. These prevent the machine operator from coming into contact with dangerous parts of the machine while it is moving. When inspecting our machines as well as the machine guards, please remember that machine guards should comply with the following requirements. They should afford the maximum protection possible. The danger zones should be blocked out during operation. The guard should be corrosion-free and fire-resistant. The guard should not produce splinters or pinch the operators. The guard should be fixtures of the machinery. The guard should not affect the efficiency of the machinery. And lastly, they should be strong enough to withstand normal wear and tear. Machine guards and safety mechanisms are designed to protect your hands and fingers. Never remove machine guards or bypass safety mechanisms. Check the lockout, tagout procedures before attempting to put your hands into machinery. Poorly maintained machinery, tools, sloppy work areas, and cluttered pathways all contribute to hand injuries. Good hygiene includes hand washing, which helps to remove germs and dirt from your hands. Clean hands are less vulnerable to infection and other skin problems, such as contact dermatitis. Aside from electrically powered tools, you are often going to be using hand tools. Now, hand tools are multipliers of our strength, and they are like millions of willing hands working for our comfort. Primitive man had no tools but his bare hands. They caught his food, built his home, but one day someone discovered that with a stone fastened to the end of a stick, he could strike a harder blow than he could with his fist alone. From this beginning prehistoric times, tools have been developed, enlarged and refined, but have never lost their importance. However, hand tools are considered so simple that usually no one bothers to point out the right and wrong ways of using them, as well as how to take care of them. Harmless as they look, they account for a surprisingly great number of compensable injuries in today's industry. Workmen have lost eyes or had vision impaired. Tendons have been severed. Bones have been broken. Arms, legs, and fingers have been infected through puncture wounds, all because of unsafe practices in the care and use of hand tools. Hand tools normally do not have guards, and the workman must provide his own means of safety. He must know how to use his hand tools safely. He must know and practice the safety precautions that will protect him from injury. He must know how to check the condition of his hand tools in terms of safety in use. This starts with proper training. Too often, it is assumed that workmen know how to use hand tools when all they know is what they have observed. There are fine points in hand tool working techniques that an individual will see but not see why. He will miss many of the steps included only for the safety of the workman. Training in the use of hand tools is an ideal starter for any safety campaign. The slogan of this safety campaign is often, "The right tool is the safe tool." It is not uncommon to observe a workman forcing a nut onto a bolt with a pair of pliers, or using a screwdriver for a job that called for a chisel. Such unsafe tool substitutions are often responsible for serious hand injuries. Make sure to incorporate into your safety campaign of hand tools the provision for a tool maintenance procedure, as this is one of the most essential factors. Hand tools in the hands of many workmen over a period of time are damaged or badly worn in use and require careful and frequent inspection if their safe use is to be maintained. When hand tools are not properly sharpened and dressed, injuries are often caused through insufficient cutting and glancing off the material being worked. A planned inspection time and place should be established and followed continually if an effective tool safety program is to be conducted. All hand tools need safe handles. A workman's inefficiency and unsafe practices in the use of certain hand tools can often be traced to the handle of the tool. If it is too short, splintered, loose-fitting, or otherwise poorly affixed to the tool, the workman is exposed to possible injury. The supervisor should be constantly mindful of their responsibility in seeing to it that all hand tools in their shop are equipped with safe, securely attached handles. With axes and sledges, a recommended safety practice is to install a steel band around the head and to bolt it to the handle. In most cases, the safety of hand tools can be determined by the condition of its cutting and striking ends, particularly in the case of edges and pointed tools, such as cold chisels. A cold chisel with a mushroomed head is a common cause of injury to workmen. When a mushroomed head is pounded, there is danger that chips will be knocked off the damaged head and fly into the eyes of the workman. Mushroomed heads on any hand tool should be redressed on an abrasive wheel. When the tips of screwdrivers are dressed, a file rather than an abrasive wheel should be used because the file draws less temper from the screwdriver tip. Loss of temper in a screwdriver soon results in a damaged tool and possible injury to the workman using it. Definite and specific procedures in the safe maintenance of hand tools should be set up. Limits of wear, frequency of use, inspection guides should be established. An efficient program on keeping hand tools safe requires periodic inspections of all operations involving hand tools. The tool supply room should be inspected at definite times. An inventory of hand tools should be maintained. Handling routines should follow a definite pattern. It is the supervisor's responsibility to enforce all planned procedures involving hand tool safety. The sharp tang of an unprotected file can make a painful and disabling wound. Keep plenty of good file handles on hand. See that there are securely fitted, substantial handles on each file you use. If any files have particularly sharp pointed tangs, round them off to avoid snagging your hand when reaching into the toolbox. When filing, work close to the chuck in a lathe. File left-handed so your arm will not be snagged on your clothing or caught in the chuck, jaw, or dog. Never hit a file with a hammer. Pieces of the hardened steel are likely to fly. Do not make a center punch or a chisel out of an old file. The metal is too brittle for this purpose. A file breaks easily if you try to use it as a pry, and the pieces may fly into your eyes. It is hazardous to carry a file in your pocket without a handle over the tang. If you should fall, the tang might be driven into your body. The cleaner and sharper you keep a file, the less chance there will be for it to slip and result in a skin knuckle or other serious wounds. Never use screwdrivers with split or splintered handles. Always use a screwdriver that fits the screw. Dress the point if it is worn, bent, or broken. Use an awl, auger, drill, or driven nail to start each screw. On rough work, use a hammer. Place the work on a flat surface. Do not hold it in your hand. For electrical work, use screwdrivers with insulated handles. Wheelbarrows seem harmless, but they might be dangerous, and often they are troublesome to handle. Here are some suggestions. Avoid using a wheelbarrow with cracked or broken handles, damaged or wobbly wheels, loose legs or ragged edges. Keep the wheel axle bearings well oiled. Balance all loads carefully, placing the center of the weight well forward to save lifting strain. Lift chiefly with your leg muscles, keeping the back nearly upright. When wheeling heavy loads, take special care if the load should tip not to be caught by the handles. See that plank runways are well supported and not able to shift or tip. If wheeling loads across portable apron bridging any open space, make sure each time that the bridge is securely in place. Watch for insufficient clearances. Wear gloves if necessary to protect your hands. Never run with a wheelbarrow. This leads to serious stumbling and falling injuries. Do not leave a wheelbarrow in a position where it may tip over or where persons or traffic may run into it. Many hands have been broken, fingers smashed, and knuckles skinned as a result of workmen striking the hands against door jambs, columns, piles of material, and other objects while handling trucks and wheelbarrows. This is why it is important to have knuckle guards to protect your hands from crushing and injuries. Just as foils are used on swords and sabers to protect the hands, circular discs can be used in many different ways in industry to afford similar protection. When placed on the handle of a pinch bar or cord mover, a disc will prevent the hand being crushed if the bar slips. When used on a chisel bar, a disc will reduce the danger of injury to the hand if the hammer misses the head of the bar. On steel used for sharpening knives, a disc is an effective guard. Here are some important things to remember for tool keepers. Issue only tools that you know to be safe. Permit no tool with a mushroomed head to leave the tool room. Have all cold chisels, chisel bars, cutters, and other shock tools with bad heads dressed before they are issued. Keep the jaws of wrenches in good condition and warn workers about misusing them. Keep all sharp-edged tools sharp. Keep the edge protected while in storage. If any tool shows signs of being improperly tempered, withdraw it from service, try to find the trouble, and have it corrected. Portable electric and pneumatic tools should be kept in the best possible condition. Check frequently the condition of switches and control valves, electric cords, and hose connections. If a grinding wheel has been abused, give it the ring test. Know the safe speed and how to mount and adjust the wheels. Store grinding wheels so they cannot be abused. When using goggles, make sure they are suitable for the work and that they fit comfortably. From behind the wall in your workplace, an invisible servant is always available to speed up and make your job easier. This servant is electricity, a most convenient and powerful source of energy. You can see or hear this invisible energy in action when it lights up a bulb, starts an electric motor, or boils the water in your kettle. Electricity is a must in a progressive industrial development, but it unfortunately has certain inherent disadvantages that it can cause fatal accidental injury when the current passes through the human body, or it can start fires that destroy property and claim lives. Despite these characteristics, more and more appliances are developed and marketed to assist us in doing a better job. Electricity has become so commonplace that we take it for granted. Just the flip of a switch. There is no doubt then that we must keep portable electrical tools safe. All portable electric tools are equipped with an electric cord. Defective cords, defective plugs, and defective extension cords are the most serious single cause of electrical shock. Attachment plugs present safety problems in their normal use, and the hazards are twofold. One lies in the numerous fine wire strands of the conductor which are affixed to the plug underneath the screw. As the screw is tightened, these fine strands tend to push forward through being compressed, and these wandering strands may come in contact with those of adjacent conductors or with the prongs. More often than not, the earth wire is completely pushed out by the action screw, thus discontinuing the earth contact or causing the earth to touch the live or neutral wire and to energize the hand tool. The other source of possible injury is provided by the cord grip on the rear of the plug. Often, this grip is not capable of relieving the strain on the conductors and are left unprotected only with their own insulation. This increases the strain on the earth conductor and may sever it completely from the earth prong. With continued flexing, a breakdown of the insulation may result. The stranded conductors can cause a short circuit, and the individual grasping the attachment may suffer a burn. Electrical injuries, though, can be prevented by using one of the following approved devices: an earth leakage, a double wound transformer, high frequency currency machines, or double insulation. Earth leakage protection is a device, if introduced into the electrical circuit, which switches off the current immediately a leak to earth of between 5 and 20 milliamps takes place. The device then works on a principle that all the electricity fed to the appliance goes along the live wire or conductor and returns via the neutral wire, also a conductor. If through faulty installation or poor workmanship, some of the electrical current escapes to earth via some conductor, which could be the human body, the line and neutral currents are not in balance and the switch will trip instantly. These devices can be fitted to the meter board or can be portable. It is considered good, safe practice to maintain the normal earthing system through 3-pin plugs of all electrical equipment and to check at regular intervals for earth continuity. Double wound transformers. This alternative requirement of one double wound transformer between each hand tool and the mains. The secondary winding may not be earthed. This means that twin conductors only are required, and the hand tools should not be earthed. It is portable and can be used anywhere. It seldom, if ever, requires maintenance. High-frequency current machines. The use of high-frequency current machines requires no apparatus other than a local generator of high-frequency current to protect the user against fatal electric shock. This is a portable or mobile piece of equipment and can be used wherever necessary. An electric, petrol, or other type of motor can drive the generator. The machines are provided with special plugs to prevent their being plugged into the main circuit, which would damage them. Double insulation. New machines are supplied with double insulation between the rotating and static parts of the machines. This does not require any other apparatus or equipment to protect them and doesn't need to be earthed. A twin conductor, 2-pin plug only, is all that is required. The international sign for double insulation is a double square. Single or 3-phase machines with double insulation are available and may be plugged directly into the main supply plug. Always inspect a cord before using it. Discard cords having damaged or cracked insulation, and switch off before unplugging it from the socket. Remember to remove a plug by the grip and not by pulling on the cord. Now, what can cause a live chassis? Many things can cause the current to change the frame of the hand tool. Water in the switch, carbon from the motor brushes, broken or loose parts in the case of the motor or switch, defective insulation of the motor windings, loose cord connections in the tool or plug, worn or defective cords. If you touch an electrically energized object with dry, calloused hands while standing on a dry floor, you may only feel a slight tingle, but make the same contact with moist fingers while wearing damp shoes and standing on a wet surface, and your resistance may be low enough to provide a lethal shock. It is not the amount of electricity in a circuit that causes death. What matters is the amount of current surging through the vital parts of your body. If the voltage or pressure is great enough to overcome the body resistance, the result is a fatal shock. Any shock from 15 milliamps or more current can kill a person. A tiny 5-watt bulb draws 50 milliamps of current. Even that low current drain is more than enough to kill a human. There have been no recorded deaths from electric shock on circuits of 12 volts or less, such as found on doorbell transformers and furnace thermostats. But death has been known to result from a circuit as low as 46 volts. If it is necessary for you as an employee to work inside a boiler, a metal tank, or other enclosures where your contact with an almost perfect ground is inevitable, you should be equipped with low voltage extension lights. By installing a 6 or 12 volt transformer outside the workplace, you will be safe with a low voltage extension light. Extension cords in particular need continuous, careful attention. The following suggestions are made. Keep connections tight. Inspect regularly for earth continuity and correct wiring. Replace rather than repair cords with defective insulation. How do you handle them? Do not support cords on nails. Do not place near heaters. Don't run under the carpets. Do not string cords across walkways, and do not overload extension cords. Of vital importance in the safety of extension cords is inspection and maintenance. Make a specific person responsible for the regular inspection of all portable electrical hand tools. Number all appliances to identify with a suitable mark and list all appliances in a register. All defects are to be noted in the register, and tools must be sent for repair when required. Abrasive wheel makers take all possible precautions to supply sound wheels, and various methods are used in their construction to reduce the risk of breakage. In spite of these precautions, though, breakage may occur in service due to a defect caused by subsequent misuse or handling. Bad storage, incorrect selection of a wheel, improper mounting, excessive out of balance conditions, excessive speed, grinding machine defects, and malpractice in grinding operations are all factors that can result in breakages. Two or more of these factors may operate together, and it is essential that every breakage of a wheel should be followed by careful investigation. Ensure that wheels are carefully unpacked, cleaned with a brush, and examined for possible damage in transit. The soundness of a vitrified wheel can be further checked by suspending it vertically and tapping it with a light, non-metallic implement. This is known as the ring test. If the wheel sounds dead, cracked, it should not be used. Often, wheel breakage can be attributed to carelessness, improper handling, and poor storage. Wheels damaged from these causes may appear perfect, yet present a danger to operators. So prevent dropping and bumping of the wheels and never roll the wheels around. Correctly store and maintain all wheels and ensure that you use the machine correctly. When storing any grinding wheels, ensure you have suitable racks, bins, or drawers to accommodate the various types of wheels that you are using. Most plain and tapered wheels are best supported on edge or on central supports. Where the wheels are placed on edge, the support should take the form of a cradle to prevent rolling, with a sufficient number of partitions to prevent wheels from falling over. Thin resinoid, rubber, or shellac wheels should be laid flat on a horizontal surface and away from excessive heat to prevent warping. Abrasive wheels should be mounted on the type of machine for which they are intended. This appears to be an obvious precaution, but accidents still occur when wheels are mounted on homemade apparatus quite unsuitable for the work. Likewise, accidents are caused by heavy and medium wheels being fitted to spindles designed to take only the lightest of wheels. As a result, vibration is excessive and breakages occur. On no account should an abrasive wheel be screwed onto the taper spindle of a buffering machine. This dangerous method of mounting is very likely to result in the breaking of the wheel owing to the wedging action of the tapered spindle. Floor standing grinders should be heavily built on good foundations. Bench grinders should be securely anchored to a stout bench. As a rough and ready rule in the selection of wheels, soft wheels are preferred on hard material and hard wheels on soft material. With wheels of unsuitable structure for the job, loading may result. This is, the abrasive wheel face becomes clogged with particles of the material being ground. A wheel may also be either too hard or too fine, resulting in glazing. The operator is then forced to use excessive pressure of work on the wheel, a contributing factor to wheel breakage. Each type of wheel has its use, and each is best suited to certain classes of work. The best policy then in selecting grinding plant is to consult the manufacturer of the machine and abrasive wheel, and do not experiment without competent advice. Now, where you have a variety of wheels kept in a store, it is the greatest and most important thing that the correct wheel is issued for the machine on which it is intended to be used. Coming back to the saying, the right tool for the job. It must be remembered that centrifugal force, the ultimate cause of wheel bursts, increases not directly with speed, but as the square of the speed. The speed at which the abrasive wheel revolves is therefore extremely important, and it cannot be too strongly emphasized that doubling the speed increases fourfold the tendency to burst. Again, it cannot be repeated too often that in no circumstances should the maximum permissible operating speed specified by the makers of the wheel be exceeded. It must be readily possible to compare the speed marked on the wheel with the speed of the spindle. The spindle itself should also be of adequate diameter and made from steel of suitable quality. When the wheel is secured by means of a single central spindle nut, the thread should be such that the direction of tightening the nut is opposite to the direction of rotation of the wheel. The spindle should be of sufficient length and threaded to a sufficient extent to ensure that when the wheel and flanges are mounted, the thread extends inside the flange but not into the hole in the wheel. Ensuring that you have a good solid work rest is also very important. Work rests should be of substantial construction, readily adjustable to follow wheel wear and be securely clamped to the machine. The rest should be kept adjusted as close as possible to the wheel face or side to prevent the workpiece from getting between the wheel and the rest, which would result in the risk of jamming and breakup of the wheel. The necessary adjustments should not be made with the wheel in motion. All rests should be examined periodically and maintained in a good condition. When the wheel slows down as the work is applied, flat spots tend to develop which lead to bumping of the wheel. In addition, the operator, to compensate for loss of grinding efficiency, may exert greater pressure and thus add to the stress of the wheel. Belt slipping or a driving motor of inadequate power may be contributing factors as well. It is important that the means for starting and stopping grinding machines should be placed in a safe position and within reach of the operator. The electric cable should be in good condition, and unless the machine is of the double insulator type, it should be properly earthed. To restrict flying particles to the smallest possible area, and to protect the operator in case of accidental breakage, and also prevent accidental bumping and cracking of the wheels, grinders should be equipped with adequate safety guards. Metal guards of adequate strength, covering the entire wheel except the actual point of operation. Removable side covers, which are always replaced after adjustments to the wheel. Transmission guards covering all drives and belts. Permanent eye shields of perspex or safety glasses in position above the point of operation. And these also must be kept clean and unscratched and always in the correct position. Hinged flaps covering work surfaces when the machine is also not in use. Even if a grinding machine is equipped with all possible safety devices, grinding is still a hazardous operation and certain operating safety rules must be observed. Cup goggles with safety lenses should always be worn, even if permanent face shields is fitted to the machine. Grinding contact should be made without bumping or impact. When the machine is switched on, it should be left running idly for a full minute while the operator stands aside. Side grinding on the flat side of a straight wheel should not be allowed. Special wheels are available for that purpose. Work should not be forced against the wheel so that the motor slows excessively or stalls. Thorough investigation should be made after a wheel has broken to find the remedy and the cause of the breakage. Keep the area around the machine clear and free from obstructions. It is a good idea to appoint one person responsible for grindstones, and they must check all machines every single day. Have you noticed someone in the area of work not wearing the correct PPE because they are only observing, or they are standing in the area but not performing the work, and so PPE does not apply to them? The Machinery and Occupational Health and Safety Act of 1983 states that the user shall cause a notice to be posted in a conspicuous place at every power-driven grinding machine, prohibiting persons from carrying out, inspecting, or observing grinding work without using suitable eye protection. The user of a power-driven grinding machine shall cause such machine to be marked in a conspicuous place with the manufacturer's rated speed or speeds of the spindle in revolutions per minute. Portable electrical equipment can be fatally dangerous. All portable electrical equipment should be suitably identified and recorded in a portable electrical equipment register. Inspections should include items such as cable and extension leads, domestic and even office equipment, and other appliances that draw power from a socket outlet. A person trained, in other words, a competent person to do the work, should be given the responsibility for checking the equipment at routine intervals and then recording the findings in a register. In order to control safety and the security of the equipment, a person qualified to do the work should be made responsible, obviously appointed in writing, and at least monthly to check for the following things: loose connections, continuous earthing, that the cable is free from any bad joints, any cracked or broken insulation, polarity of extension cables, that all switches are in good order, as well as the plug being in good order.